I'm gonna need this for 6th period. All right, ladies and gentlemen, we're talking about lesson 13. Okay, so hopefully today will be a little fun for you guys, a little interactive. We're talking about the horror movie shuffle. Okay, and the whole goal of our lesson for today is to understand the difference between something being because of chance or for real based on like a bias. Okay, so an outcome being that, oh, it just happened that way, or there's an actual bias at play. Yes, thank you. All right, so the objective of our lesson for today is that you will understand that just by chance, you can see differences between two groups and that these differences are usually very small. Okay, you will learn that by calculating differences in the percentages between two groups, you can determine if outcomes are due to chance for categorical variables or if there's an actual like difference or a skew or bias that's present. Okay. Our essential concept is a long one. You can shuffle data based on categorical variables and by using the difference in percents. The distribution formed by shuffling represents what happens if chance were the only factor at play. So we're going to take a set of things and we're going to shuffle them randomly, right? And that's going to be us creating this shuffle by chance. No, I'm going to do it for you guys. You guys will be doing it on our studio for your lab starting tomorrow. Okay. If the actual observed difference in percents is near the center of this shuffling distribution, then you could conclude that chance is a good explanation for the difference. So if a lot of the shuffles come out with the same difference in the percents, like or very close to each other, then you could say, yeah, it is by chance. However, okay, if there's extremes where like one's in the middle, one's over here, one's over there, one's over there, then you can conclude it's not really by chance. There's something else at play there. Okay. Sometimes the apparent difference between groups is caused by chance, and sometimes there's a bias. Okay. Or in like a real difference there. So you guys will hear 4 vocab words today, quite a bit. Chance, right, which we'll talk about. Simulations, which we've been using in our studio. Randomness and shuffle. Okay. So first things first, let's take a look at our stress and chill campaign from last week. Let me open that up for us. And let's see how we're doing so far and who our top survey takers are. Okay. Let's see. I'm not going to call out those who are low. I'm just going to congratulate those who are on the leaderboard. Yeah, I can see who's made the most entries. Hey, check this out. Okay, so top 2 survey takers, Isaac Velez and Devin. Okay, and then they each have 13 right now. And then we have the 12s. I have like 5 or 6 kids who have 12. That's Victor, Carter, Celeste, Audrey, and Melanie. Dallas, Audrey Salcido, she's at 11th grader. Dallas, you have 11, which puts you in the top 10. Okay, but y'all got to step it up. This is sad. Dario, you even lagging it, man.
Damn, how many are you supposed to have? I don't know. Right, because it's like, damn.
So when did we start this? Last week on Thursday?
Last week on Thursday, yeah. Munya, I'm looking for you, hon. You have 7 so far. Let's see. Okay, we're not gonna do this for everyone, guys, but you have 10, Dario. All right. So if you're behind, okay, and you want to catch up, then do your survey 3 times a day. Once when you wake up, once in the middle, like when you're at school, like around lunchtime, and once after dinner in the evening. Okay. So you can do your survey 3 times if you need to catch up for the rest of the week, because we will stop doing this probably Friday. Friday will be our last day of entries. This Friday. Yeah. We're not doing this for very long.
So if we go into our end, can we see how many entries we put in, or is it
I believe so. Yes, you can. So if you go under monitor, you should be able to see how many entries that you've put in. Yes. Okay. All right, ladies, please keep putting in your surveys. It is very important that you keep putting in your surveys. We need, like I said, last day for entries is going to be on Friday. And then I'm going to be checking for entries. Remember that 20 entries will get you 50 points. Okay. 20 entries. You need 20 to get 50 points. And again, I will also see if you go in and do 20 entries back to back. So that's not cool. Don't mess up our results, y'all. Don't mess up our data just because you're lazy. I see you. All right, we're going to kick things off with an IDS journal entry. So this is the first question for lesson 13, and it's actually related to our survey. So think about if you've been taking your survey, if you haven't, when you've been taking it, all that stuff. And I want you guys to answer the question of how can you be more accurate in your data collecting for the stress and chill campaign? Okay, accurate can mean how can you be more specific in the information put in, or maybe accurate can mean actually putting in the survey. So how can you be better about it? Okay, 2 minutes to do that. That's okay. You can only put your truth, right? We're not asking you to make up your stuff. Yeah, just the first one. No, well, I'll give you examples before I ask you to write it. All right, ladies and gentlemen. So hopefully you wrote something meaningful and you'll actually take it to heart. Okay, so let's continue on with our lesson. So recall, we have some, we are referring back to the idea of chance. And the first time that we were actually introduced to this idea of chance was in lesson 9, like in unit 2 or section 2, I'm sorry. So we're gonna try to remember, what have we learned about chance? Okay, remember some synonyms that you guys came up with were a possibility, right? The prospect or the likelihood of something happening, an expectation of something happening unintentionally or unplanned, right? But the actual definition of chance that we want to have is that chance is a possibility of something happening. That's all chance is, right? Chance is the possibility of something happening. So you have the chance, you have a chance of winning the lottery. There's a chance because there's a possibility of it happening. The probability, on the other hand, of winning the lottery is probably really low, right? The possibility or the chance is there, but the probability of it happening, low. So chance is just the possibility of it happening. Probability is the likelihood of it happening, right? So we want to make sure we understand that when we talk about chance versus probability. So think back to the path that we saw in lesson 9, where we started off with chance, and then we moved on to probability, and then we moved on to simulations to help us figure out the estimated probabilities of something happening. So you can use simulations to show that sometimes when you think two groups are different, the difference is really just because of chance or randomness, and doesn't really mean anything that much. Like, it doesn't really mean anything as far as the difference goes. So these are two really good things to write down. Remember that a simulation is a model for creating random outcomes, and that randomness means that something just happens without a specific order, right? It just happens. Random occurrence, we call them. Okay, so I'm gonna give you guys 30 seconds because I know some of you guys at home want to write that down or get that down or take a screenshot. Okay. Oh, my bad. There you go. Said I would. Okay. So let's talk about some comparisons of groups. Okay. So below are some examples for comparing two different groups. And this is what I was talking about, where I'll give you examples when you ask. Okay, so one statement is men earn more money than women for some work. Right? I'm comparing men and women and the money they get for work. Basketball players are faster runners than baseball players. Right? My two groups, basketball players and baseball players. Kind of, yeah. Well, it's not this or that, but it's a comparison. It's like this and this, like, have this kind of outcome. Yeah, this and that kind of deal. So UCLA football players are better athletes than USC football players. Right? Some of these are controversial, yeah. And you and a friend flipped the coin 10 times. You got more heads. Okay. So you can always make a comparison. So I can literally say, senior grades are worse than junior grades. That's a comparison, senior versus junior, right? I can say the employees at Walmart are meaner than the employees at Target, right? So the idea, what I want you guys to do next is I want you to list other situations where two concepts or two groups could be compared. Okay, but pay attention real quick. After you list your situations, sometimes differences between two groups are real differences, but sometimes they might just be due to chance. So real could mean that there's a bias that we can see, right? Chance could mean I just looked at, like, maybe I just walked into Target one day and Target person greeted me and said, hey, and I walked into Walmart and the person didn't say anything to me. And so that's why I said Walmart employees are meaner than Target employees. That's by chance, right? That's not a pattern. That's not a bias. That's just one of those things where it's like, these are the two things I have to compare. Okay. So I want you guys to think about, after you write your situations, I want you to think about whether these differences are either real, meaning there's a true bias there, or there's a true difference that we can, like, see, or due to chance, based on, like, a chance situation, right? So you're gonna write chance or real for your statements, as well as the statements that we saw up here, okay? So you're gonna answer both of these IDS entries here. And I'm going to give you guys 4 minutes to do so. Yeah, the ones you wrote and these 4. Yes, exactly. So determine if it's real or chance, right? For the statements you wrote, as well as these 4.
So we had those.
Yes, yes. Yeah, good. Good question. Yes, adults. So, but if you want to phrase that means like between 18 and like 25 or something like that, you can call them young adults. next to your statements, and then for these statements, you can just write the statement down or do the gist of the statement. So you can do like men versus women, and then, you know, basketball versus baseball. You can. I mean, we're going to talk about it, so have reasons that you can communicate. What's up with? You don't what? When did this happen?
That's why I was thinking like here.
Not right now, though.
I'm not.
My bad. Sometimes I'm not good with social cues. Keep it in your journal, Val, because I'm going to be calling on people to share. Oh, yes. You heard me right. All right, you guys have 45, actually 40 seconds left. All right, everyone be on your toes because I'm going to call on y'all. All right, so let's hear them. Okay, so Maya, what do you think? Men earn more money than women for some work. Is that a real bias, or do you think that's just by chance? Mhm. What do you think, Maya? You say real? Okay, what do the rest of you guys think?
I say the second one is chance.
Hold on, we're not talking about the second one yet. Still on the first one.
Well, the first one's real.
Real, okay, so
Mhm.
I say bias. I mean, because bias pretty much like
yeah, real and bias are the same thing, Matthew. Yeah, real means that there's a real bias. Okay. So yes, I would say so. In a lot of careers, right? There's definitely a bias. For the second one, I want to hear from Tyrese. Mr. Tai. Basketball players are faster runners than baseball players. What do you think? Real or chance? Ah, Tyrese says chance. Matthew says chance. Evelyn says chance. And then Alexander was saying chance earlier. Okay. All right. What do you guys think? Chance?
chance.
Yeah, for sure. Right? Yep. Okay. Let's take a look at the third one. Third one, I want to hear from Stephanie. Miss Stephanie. UCLA football players are better athletes than USC football players. What do you think? What do you think, Steph? Steph, are you there? Okay, what do the rest of you guys think? Real or chance? Thank you. Some of y'all were ready to go. Okay, so I'm seeing it here. I'm sorry, let me do this, guys. Since we're just responding to the things. So a lot of people are saying chance, right? Because it's very subjective, right? In the sense that like I could literally see a UCLA football player and a USC football player just working out and say like, oh, he's stronger, he's lifting more, so he's a better athlete. Like, you don't know. And then, it's one of those inductive reasonings. You see one example and you like just put it to the whole, right? That's right. Throw back to geometry for y'all, some logic. And then let's see, you and a friend flipped the coin 10 times and you got more heads. What do you guys think? I'm not calling anyone for this
That's
one.
chance.
Chance. Well, I mean, it can really happen, but there's no bias there, right? You can't have any bias on a coin. It's a 50-50 chance thing. So in this example, it's actually chance. Okay. Okay. David's like, you never said what kind of coin it was. All right. Kenya could be right. That's true. Maybe it's a bias coin. Maybe she's got a two-sided or a two-headed coin. All right. All right. Okay. Good discussion, y'all. Good discussion. So let's move on to, okay. So let me ask you this question now, linking it with our horror movie idea. And I wanted you guys to write down your thoughts about the following question in your journal. Do you think men and women have an equal likelihood, aka chance, of surviving by the end of a horror movie? Write it down. What are your thoughts? Write it down. So I'm going to give you guys 2 minutes to get your thoughts down in your IDS journal here. Okay, 2 minutes for this question. Not the question, hon. Write your answers to the question down. In your journal? This should be the last question in your journal for lesson 13.
Oh, that's what we just did.
Yeah.
Oh, I put that over the list of the situations.
It's okay. You can always copy and paste that. Okay. So this is the last question in your journal. And then we're going to move on to the activity. Unmute because I wanted to mute. All right. So what do you guys think? Let me have it. What do you guys think? Do men and women have an equal likelihood?
No, I don't think women have a chance of surviving horror movies because they get sometimes when they watch horror movies they get scared.
Wait, are you talking about inside of a
No, inside a horror movie, like they're a character in a horror movie.
Oh no, I don't think. Well, I think a woman could survive. Women could survive a horror movie. like
Alright.
inside it, I think they can survive it.
All right,
Because
Dallas.
in movies, women are like they're like smart. Women they're like smart in horror movies. Women are like smarter than men.
Versus men, they just be like, oh, let's run to the attacker and try and kill him. I'm just gonna be like running away. How about I go this way? Like,
Okay, so Dallas agrees with you, Alexander. She says
Uh-huh.
women are smarter in horror movies because they actually like
Yeah.
flee the scene.
Yeah, they are.
I feel like in horror movies, the guys are always trying to be macho.
Yeah.
Right, like we all
All right, so Vicky says everyone has different survival skills. Okay. Maddie.
And basically, when men are in horror movie and they're getting and they just run away from everything in horror movies.
Yeah, that's cool because that's how you survive. Okay.
And women they face their fear in horror movies.
That's also true. That's true. Okay, Maddie says she watches a lot of horror movies and
I
sometimes
do too.
because they think and have great skills. It's all about the mind, man, and it's
Yeah, it is.
women are smarter than men. No, I'm kidding. I'm kidding. All right, thank you, Alexander. So you guys think women have a better likelihood? Anyone think that it's like even?
I said it depends because like you don't know the person right next to you that's in the horror movie. I mean, like you don't know what kind of skills they have. You can't really read their mind.
Interesting. You guys, I love how you guys are really like giving this thought with the horror movie because I don't think horror movie writers actually give this a lot of thought. I think they just like, oh, let's kill this person off and that person off. But I'm not a horror movie watcher like Maddie seems to be. Okay, so it depends on characters. Val says it based on the person's knowledge and skills. Evelyn says she loves scary movies. Evelyn, you and I, not a movie we're gonna watch together, hon.
Wait, well, what if it's like a group, like, what if we have like a scary movie where it's all men and then there's a scary movie where it's all women?
That's never gonna happen. There always has to be both genders so that both genders are drawn to the theaters. Yeah, there's never gonna be a movie where it's all men because then the guys won't go to watch it. And there's never gonna be a movie that's all girls because it's a scary movie because then the girls won't go to watch it. So no. There's a formula, guys. There's a horror movie formula, I promise you. All right. So lights, camera, action. Today, you will be pretending to be the producer of a horror movie. As a producer, you obtain data from 50 horror movies, sometimes called slasher films. There are a total of 485 characters in these 50 films. We're not just talking about main characters, right? We're talking about characters in general, like all the characters. So there are a total of 485 characters in these 50 films. 2 variables were recorded for each character, gender and survival. The values for the gender variable were male and female. So for the gender variable, it either says male or female. The values for the survival were dies or survives. So they literally looked through 50 movies and they said, okay, female dies, female survives, male dies, male survives. Like they categorize every single character, right? So then they took this categorical data and they did some summary statistics on it, okay? The percent of total survivors was calculated by dividing the total number of survivors by the total number of characters using the following code. So they went ahead and they tallied how many survived. Okay, so they tallied how many survives there were, and then they divided that by the 485 characters total. And what they found was that only 18% of all characters survived in these slasher films. The percent of survivors was then calculated for each gender. So in other words, they took all female characters and they looked at the number of female survivors and divided it by the number of female characters there was. And then they did the same for the male. So they saw, okay, how many male survivors were there? And then divided it by the how many male characters there were. Okay. So they found each individual gender survival rate. And what they found out was this. We're going to do this presentation mode. Come on. What they found out was this. By the end of a horror movie, about 23% of females survived. And about 13% of males survived. So I want you guys to go ahead and on your activity, we're now in the 2.13 class activity, okay? In your activity, give me a second, I'll get you some tissues, okay? In your activity, I want you guys to answer these 3 questions. Is this what you expected? 23% female versus 13% male survival. And then what is the difference in the proportions of the survival rates? So literally difference. What's the difference between these 2 rates? And what does this mean in the context of surviving a horror movie? And then is this difference big or small? Can you define what is a big difference and what is a small difference? Okay. So I'm going to give you guys about 3 minutes to answer these. And then we'll look over them. Mm-hmm.
On the student side, it said how many
485 characters total. And 18% survival rate for overall characters. It didn't actually tell us how many female characters there were and how many male. Katie, yes, finally girls for the win.
you said 480 or 450?
485. Yeah. I bet you his allergies are flaring up. Well, guys, you're answering these questions on your 2.13 horror movie shuffle class activity. So we're done with our journal for the day. We're working on the activity. Okay, we got a minute left. So think through your answers. No, these I made. All right, so let's take a look. Okay, is this what you guys expected? Not really. You didn't expect the survival rate for females to be higher?
Well, I mean, I did, but like,
Ah,
Yeah, I was expecting this, like, probably just a little more.
okay. So you're saying that that's a huge gap. You didn't think that would be that big of a gap. Okay. All right, so Alexander and Katie said, yeah, they expected this. Maddie said she's not surprised. All right. Okay, let's see who else. Haha, usually females survive more often, yeah. Natalie says she expected this too. So if you did expect this, right? If you thought males would survive more, then you're in for a real big shock, right? If you thought females would survive more, then these results are what they're expected. And maybe they're kind of like you did expect the females to survive more, but not at a 23% versus a 13%. Okay. And if you thought there was an equal likelihood of survival, these results would also be surprising too, right? Because they're not equal, not even close. The second question was, what is the difference in the proportion rate? So remember, whenever I ask you that, I'm literally asking you the difference. Like, do 23% minus 13%. So what does this mean in the context of surviving a horror movie? Right? It means 10% more females survive in a horror movie, right? 10% more women characters survive than men. That's what that means. And then as far as, is this a big difference or a small difference? Okay. What do you guys think? Do you think 10% is a big difference?
Yeah.
Yeah? Now,
In terms of survival.
in terms of survival, what do you think?
I was just saying that, just thinking about it, because how many characters in total were there?
485.
485. I mean, I would say it's small because it's only a 10% gap in that 20.
Okay, so you're saying it's small. You guys are, okay, so you're each saying it's small, right? Okay, so some people are also saying small, some people are saying big. And in reality, we have no way of knowing. Because we really don't have anything else to compare it to as of right now, right? So upon first glance, it might feel like it's a big difference, but in reality, until we start comparing it to some other simulations, maybe, we won't be able to know. So that's actually what we're gonna be doing here. I actually want to exit presentation mode, I apologize. What we're gonna be doing here is we are going to be participating in an activity to determine if the 10% difference seen in the actual data set is big or small. So this will help us determine if there really is a difference in horror movie survival rates for males versus females, or if this 10% difference was just due to chance. Okay. So what we're gonna do is I'm gonna give you guys a class poll real quick. And what you're gonna do is you're literally gonna tell me, are you male or female? Okay, that's what you're gonna tell me. Are you male or female? So are you male, female? Yes, I know. For some of us, this is a difficult question. For some of us, not so much. And that's okay. Yes.
So you know how we're having the senior awards night?
Mhm.
Mr. DeLuise is sitting like, oh, make sure you RSVP and stuff like that. But how am I supposed to get the award? Because I don't want to go if I'm not gonna get an award. Like it don't make sense for me to like come along and come and then this and that all the time. Like, that's cool.
I think everyone is getting an award of some level.
I think only 76 people.
Right. The only kids that are not officially getting a reward are the kids that are currently not set to graduate. So if you're set to graduate, you're getting an award of some sort. All right. So far we have 11 females, we have 5 males. Okay, so please continue to take the poll. For those of you guys here, I'm assuming male, male, female, female. Yeah, is that an okay assumption? All right. Okay, so we have, let me grab some paper. Okay, but in general here, we have 1, 2, 3, 4, 5, 6, hold on. 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. Okay, so we had 17 female. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 mil. Okay. So what I was just counting how many the kids we have present in class right now. Because we have way more, but we have like 6 absences, so maybe probably more. No, we have like 8 absences. 10 maybe? I don't know. Oh yeah, no, we have like 9 absences because we have 27 kids in the class right now. That's including you guys, right? And we have 36 kids on our roster. So we have 9 absences right now. All right. So in our Zoom, we have 7 male and 15 female. One of our males didn't take the Zoom poll, just saying. Huh?
Are we your biggest class?
You're tied.
With who?
5th period. What does it matter, dude?
It doesn't matter, but it matters because we better.
Okay. Sure thing. All right. Huh? 17 females, 11 males. Yes. Okay. So what we're going to do now is we want to calculate how many male or females would survive with our class numbers. So how we're going to do that is we're going to use the 23% and the 13% survival rate. Okay. So over here, we should have 17 males, right? As I'm sure, assuming I'm sorry, 17 females, and we should have 11 males. I know I said 10, but 11 as I was missing one. And to calculate how many females are actually going to survive, we're going to take our 23% rate at 0.23, and we're going to multiply it by the total number of females that we have. So 0.23 times 17. And we get 3.91, right? Which we're going to round to 4 females. So we're going to say 4 females survive. Okay. Okay, so for males, you said 0.13 times 11 is what? 1.43. So we're going to round that to 2. We're going to say 2 males survive. Okay. So you're like, okay, great, Ms. K, this is wonderful, but what are we going to do? So over here, what I'm going to do is I'm going to take this, and before I give you guys access to it, I'm going to make sure that we have the correct numbers, okay? So over here, I want to make sure we have 17 females total with 4 survivors. So 1, 2, 3, 4, 5 survivors. So we're going to change one of these guys to dead. Okay. But let me make sure I have 13 dead. So I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I was at 9, right? 10, 11, 12, 13. Okay, so that means these females, bye-bye. Okay. And then for the guys, I have 2 survivors, so we're going to leave those guys. So that means I should have 9 dead guys. 1, 2, 3, 4, 5, 6, 7, 8, 9. So that means these guys need to bye-bye. Let me double check with the females. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Perfect. Okay. So what I'm going to do now is I'm going to give you guys access. And I'm going to make you guys editors for like 2 seconds. Okay. I'm going to give you guys access to the sheets. And I want you guys to just write your name in the name column. Pick a survivor or a dead. Okay. But if you're female, pick female. If you're male, pick male. Okay. So put yourself. So for those of you in the class, I'm going to make sure that you guys get access to this real quick. So we got David. We have Dallas, we have Munya, and we have Dario. Okay, and I'm going to send you guys the link. You will most likely need to copy and paste that link. Not going to lie. Okay, so check it in your Canvas inbox. I just sent you the link in your Canvas inbox for those of you that are in class. For those of you on my Zoom, okay, for those of you on my Zoom, it's coming your way through the chat, okay? So click the link in your chat. Now, the second you're on here, pick a box, write your name in it, and then leave the box, please. Move to the right in a column that's not being used so that people can see your name populated there and they don't write over your stuff. Don't erase the female. Just write your name under name.
I go in this round.
Pick whichever one you want. Who's this? All right. Look at Dario and David. They took both of the survivors. I'm a survivor. What happened?
I said I was literally just singing.
I know. It's like, what happened to Destiny Child? I know. What is up with this, ladies? Do we not want to survive? Alexander, you cannot be female, my dear. You are male. Well, I'm sorry. I shouldn't have said that. You identified as male when you took the survey, so I need you to be a male. Do you guys see the random number generator changing as people are writing things in?
Yeah.
So that's going to help us.
What does it do?
It's going to help us randomize. You see? It's going to help us randomize the order, y'all. Mouse tool. All right. Okay, y'all. Leave the box once you're done writing in it so people can see your name populate. Okay, Alexander just literally wrote over your name, Daria. He just really wants to be a survivor. We're just gonna put Alexander right here. Okay, thank you. I mean, that ain't cool, y'all. Where did you put him? I don't see him.
Just above the.
Oh. Y'all, you guys cannot erase other people's names or else that's not cool. Seriously, y'all, come on.
You were fast enough.
Okay. Time's up. Time's up. I'm going to take away your editing privileges, y'all. What? Okay, that's brutal. Done. You are no longer allowed. Okay. So wherever you ended up, that's where you are. Okay. Wherever you ended up, that's where you are. Now, what we're going to do is we're going to shuffle things up. Okay. So over here, I have a random number generator. And what I can do is I can take these random numbers that have been generated. I'm going to copy that. Why are you reconnecting? And then I'm going to paste it, but I'm going to paste the values only. Stop. Why? There you go. Paste special values only. So what this is going to allow me to do is now I can sort these numbers with my survivor or dead column, and it's going to rearrange the numbers based from small to big. Sort. So now what we want to do is we want to see where our survivors ended up. Okay. So if we take a look here, we have a female survivor, Natalie, surviving now. We have another female survivor, Valerie, surviving. So we only had 2 females survive based on this shuffle. All of my other survivors were male. We got 2 nobodies who survived. Male, 3 nobodies who survived in the male, and Ishmael survived. Okay. So yeah, we had 2 female and we had 1, 2, 3, 4 male survivors. So what we're going to do now is we're going to come over here in our chart and we're going to put that we had 2 female survivors and we had 4 male survivors. And we're going to calculate the proportion. So the way we're going to calculate the proportion is This is going to be 2 divided by 17 because we had 17 total females, right? And we're going to calculate our own proportion there. 2 divided by 17 is 0.12. Okay, we're going to round that. And then I'm going to do the same. 4 divided by 11 because we had 11 males in our class. So 4 divided by 11 is going to be 0.36. Oops, not 0.036, 0.36. And then you're going to calculate the difference in the proportion. So you're going to take the female survivor rate minus the male survivor rate. So 0.12 minus 0.36. Okay. And that's going to give us, what is it? Negative 0.12 minus 0.36. That's going to be a negative 0.24. Oops, not. Yes, you are. Sorry. Okay. So we have a negative 0.24 here. Okay. It's okay if it's negative because sometimes there's going to be more male survivors and sometimes there's going to be more female survivors, right? So if it's negative, that means there's more male survivors, which we saw that in this case. So I'll give you guys a few minutes. Okay. I'll give you guys a few minutes. And I want you guys to answer these questions here. Okay, I kind of skipped over them here. How many people total in your class are survivors? What is the total proportion of survivors? How many of survivors would you expect to be male or female? And then I want you guys to answer this. How does the difference, this negative 0.24, compare to the actual data sets difference, that 10% that we had? Okay. So I'll give you guys about 3 minutes to answer those 3 questions, and then we'll continue on with our shuffling. Ooh, Kenya, I'll put you down somewhere, hon. I'll put you down somewhere. Let's see, where are we going to put Kenya? Here, we gotta. No. No, it won't shift anything, huh? You might not have hit enter, and I'm sorry, you might not have hit enter, Kenya. Oh, okay, I'll move her. Okay. Oop, hello, right over there. Okay, so. For the first question, these 2 questions is based on this. Yeah. Yeah, that was my bad. I forgot about those questions. Okay. Got a minute and 40 seconds left. You guys are doing a great job so far. Okay, 30 seconds, so wrap up your answers here. So the next part is gonna be fun. Because I'm gonna shuffle, you gonna calculate. I'm gonna shuffle, you gonna calculate. I'm gonna shuffle, you gonna calculate. Okay. All right. So for the next part of our activity here, I'm gonna shuffle our data 4 more times. And what we're gonna do is after each shuffle, you're gonna look at how many female survivors there were and how many male survivors. And then you're going to go ahead and calculate the proportion of female survivors, the proportion of male survivors, and then do the difference in those proportions, okay? Remember, our total number of females was 17 and our total number of males was 11, right? So that's what you're dividing by here. So I'm gonna go back to our sheet here, okay? And what we're gonna do is I'm gonna do this because I want these guys to, here, we'll put Miss K on here just in case. There we go. I'm sorry? The number of females in the class is 17. Oh, that for the first one, it was 2, yes, but I'm gonna redo it now. Okay, so paste values only. So what we're gonna do is I'm going to reshuffle here with my new numbers. All right, let's see where our survivors ended up. So for females, let's see. We have 1, 2, 3 female survivors. 1, 2, 3 male survivors. So what you're gonna do is in your chart here, you're gonna put 3 female, 3 male, and then you're gonna go through and you're gonna do the calculations for the proportion. So 3 divided by 17 for the female, 3 divided by 11 for the male. And then do your difference. While you guys are doing that, I'm gonna reshuffle. Okay. So when you're ready for this shuffle's data, go ahead and look up here. So look at your screen. So you have 1, 2, 3, 4 female survivors for this shuffle and 2 male. So our next one should be 4 for female, 2 for male. Go ahead and do your calculations of the proportions. I'm going to do my next shuffle. Okay. Next one. 1, 2, 3, 4 female again, 2 male. Again, 4 and 2. That's lucky. All right, is that the last shuffle? Nope, yeah, last shuffle. Coming your way. All right. Last shuffle gave us 1, 2, 3 female, 3 male. Hey, we got some repeats, making sure life easier, doesn't it? Okay. So 4 divided by 2, or sorry, for 4 divided by 17. And then 2 divided by 11. Okay. So second and third shuffle were 4 and 2. Last shuffle was 3 and 3 again. Okay. So over here, we should have 0.18. 3 divided by 11, 0.27. So 0.18 minus 0.27 equals negative 0.09. For which one? It was 0.176. So you round this the 7 up to an 8.
Rounded.
Yeah. Okay, so for this one, we have 0.24. 2 divided by 11, 0.18. So over here, 0.24 minus 0.18 will be 0.06. Ah, crud. What did I just do? Cancel. Okay. And then, of course, these repeat, right? 0.06 and then or negative, I should say, 0.09. Round as you need to round. So if it has you round up, you round up. If it stays the same, it stays the same. Does that make sense?
Yeah.
Yeah, round normally. Okay. So here are differences, right? This is what we should have. So we had a 0.1, but then we had a 0.09, a negative, and then we had a positive 0.06, and then that happened to repeat. So based on our shuffles, you guys, I want you to answer these questions here, okay? What is the biggest difference we saw from our shuffles? What was the smallest? Right, difference meaning difference in our proportions. And what do you think this dot plot would look like if you shuffled your survival cards 1,000 times? Remember, dot plot is like each number gets placed at a dot, right? Or where would it go? What do you think it would look like? Would it be a bell? Would it be skewed? What do you guys think? Okay, so I want you guys to answer these questions for 2 minutes, and then we're going to go back to our PowerPoint presentation and finish up our lesson. It feels fast, but we're 10 minutes away from the end of class. I'm glad to hear that though, that it was engaging for you. So go ahead and finish up, write your answers to these. I think about the dot plot is like when you put the dots above the numbers, right? So you get like it's kind of like a histogram, but with dots. Okay. So think about what the dot plot would look like if you did the shuffle 1,000 times and you got the difference value 1,000 times.
Three survivors, dot, 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 dot. Three survivors, dot, 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 dot.
Yeah, no. So it'd be like, okay, so if females are 2 survivors, so you'd put a dot over the 2. Right? Or it's actually a dot plot of the differences in the rates. So it's a dot plot of these values right here. So you'd put like a dot over the 0.1. And you put a dot over the 0.09.
For
Or
how many survivors?
for the differences. We're not looking at the number of survivors. We're calculating the differences of the proportions of the survivors.
Oh, or if there was 1,000 of those.
1,000 of these differences, yeah. So you shuffled it 1,000 times, you got the proportions and you did the difference 1,000 times, and you're making a dot plot of the differences. Yes. Good clarifying questions. Skew means when the peak is to one side or the other, right? So regularly it's in the middle, like it's like a bell curve, right? Right skewed means that it's like skinny on the right side and goes up on the left. Left skewed means it's skinny on the left side and goes up toward the right. All right, go ahead and finish up your statements here. Okay, and then before class ends, make sure you had turn that in. So this brings us to our final questions, which you guys are working on right now and finishing up. Okay, so let's talk about what this actually means. What do those numbers mean to our overall question of, is this 10% of women surviving more than men? Is that by chance, or is that a real thing? Is there a bias in place in horror movies, right? So what we're gonna notice is this. We didn't see 10% a lot, huh? In our differences. We saw 0.09, we saw 0.06, but we didn't really see a lot of 0.1s or anything close to that. So what this tells us is that the 10% survival of women more than men is actually not by chance. It is a bias in horror movies that the females survive more than the males by 10%. Okay. So this difference in gender survival, since we rarely saw it in our shuffles, then we can say that it's not going to be by chance. We can see that there's a bit more skew toward the female survivors. So horror movies are designed in a way for women to survive more. And it could be for all the reasons that you guys were saying, right? And the way we're seeing that is because the 10% was rarely seen, that difference, that 10% difference in the proportions of survival was rarely seen. It's not happening often. So that tells us, you know what? This isn't a by chance occurrence. Because if it was a by chance occurrence, we'd see it happen in the shuffles. Does that make sense? So it seems that horror movies actually favor survival of female characters. So then that begs to ask you the question of, if you were in a horror movie, would you want to be a male character or a female character? You actually want to be the killer?
Since that's not an option.
Interesting. All right. Okay, so stay tuned for scenes from our next episode. Y'all, when I was making this PowerPoint, when I was making this PowerPoint, I was in such a corny mood. I was like, oh, we're gonna make this fun. Stay tuned for scenes from our next episode. Next class, guys, tomorrow, essentially. We're gonna start our Lab 2E, which is essentially you guys are gonna be doing your horror movie shuffle. You're gonna be doing this as a similar activity, but in our studio. So you're gonna be doing it with Cope. Okay, so you're gonna have the data, and then you're going to shuffle it up, and you're gonna see your survival rates and all that wonderful jazz. So you'll be working on Lab 2E tomorrow. Tomorrow's a minimum day, so you only have about 30 minutes. So you'll be working on it tomorrow and Thursday, and possibly Friday. Okay. It's not, no, but I feel like every time you get into class, you're gonna take like 5-10 minutes to get started. So you're really only gonna get like 20 minutes of work time today or tomorrow and Thursday. So I figured just give you guys Friday to finish it up and actually hand it in. And hopefully you guys take advantage of my niceness, okay? And actually use that time. So if you enjoyed today's lesson, I'm so happy to hear that, okay? Next week, we're gonna be doing the Titanic shuffle. Okay, we're gonna be doing the Titanic shuffle, and we're gonna see if there was any kind of, what was the difference in survival rates in the Titanic based on your ticket price. So essentially, did more rich people survive, or were the poor and rich pretty much equivalent, okay? Your homework, my dears, your homework. Please continue taking your survey at least twice a day, morning and evening. Like I said, if you missed a few, you can make it up by squeezing in a middle of the day survey in there, Okay, but they shouldn't be like one after the other. Got it? Capiche? Capiche. That's it for today, ladies and gentlemen. I hope you enjoyed it. Make sure you turn in your 2.13 class activity so you get credit for that. Have a wonderful day. I'll see you mañana.
Bye, Miss
Bye, Miss K.
Bye, Miss K.
Bye. Bye.
I'm gonna buy a Browning Polo watch.
Okay.